Assalamu alaikum students. Today we start exercise 3.3 numericals. In first question we find determinant. We expand it by row 1. In row 1 there are 3 elements: 5, minus 2, minus 4. We expand by these elements. First number is 5. When we write 5 and inside the determinant we write the values except row 1 and column 1. These are minus 1, minus 3 and 1 and 2. And then next number is with minus sign and minus sign of formula. First number with plus sign, second number with minus sign, and its values, we write its values with the cross values row 1 and column 2. Except row 1 and column 2, we write 4 values in the determinant. Next number is minus 4 and we write sign with minus 4 is plus. First number with plus, second with minus, and third with plus. And its values, when we cross first row and third column, the 4 values in the third determinant. And then we find their determinants. Determinant by cross multiplication. Minus 1 multiplied by 2 and minus sign, and then minus 3 multiplied by 1. In same way the remaining 2 determinants, and then simplify it to find the determinant of 3 cross 3 matrix. Next is same question, we find determinant, but it is lengthy calculation in this question. We again expand by the first row. In first row 3 element a plus l, a minus l and a. We write a plus l and then the values inside except row 1 and column 1. And second element a minus l, we write their sign, negative sign. And third element is a, we write a and sign plus sign, and then we simplify it to get the answer. The next question, we show that the determinant is 0 without expansion. Without expansion means we apply some properties of determinant. In this determinant we apply column 2 minus column 1 and column 3 minus column 2. Column 2 minus column 1 means second column minus first column. 7 minus 6, 4 minus 3 and 3 minus 2, and the same way column 3 minus column 2. Now 2 columns are equal, therefore the determinant is 0. This is the property of determinant. If 2 rows or 2 columns are equal, the determinant is 0. In second part, column 1 minus column 2, and then 2 columns are equal, Therefore the determinant is 0. Third part is same like 1. In this question, we verify the property of determinant. In third column, there are two values are adding, a11, a13 and alpha 13. Now we expand it by column 3. In column 3, first element is a13 and alpha 13, and we cross values row 1 and column 3, the remaining value in the determinant. Now second element is a23 and plus alpha 23, and we cross row 2 and column 3, the remaining value in the determinant. And in next, third value and its determinant. Now we apply distributive property on determinant. a13 multiplied by the determinant and alpha 13 multiplied by the determinant. This determinant we multiply in the bracket with a13 and alpha 13, and also this determinant a23 and alpha 23, and same like third. Now these are the values of these determinants. If we expand these determinants by column 3, they gives same value. We call it question 1, and then we right hand side expand by column 3, it gives the same answer. Now this is show that it means we can find determinant. Now we expand simply by the direct rule by expanded by first row b plus c minus a and plus a. There are three elements. With first element we write plus, with second element we write minus, and with third element we write plus, and between their values by crossing the row and column, and then we cross multiply these values to simplify. Carefully solve these questions. Now in this question we expand by r1 and we get the answer. Same in this way, we solve it by r1. Now in this question, two determinants are equal. In left hand side, we multiply column 1 by x, column 2 by y, and column 3 by z. If we multiply, then we divide it by the same value. And when we multiply, it becomes like that, and then we common x, y, z from column 3, interchange r1 by r2, and when we interchange and we write negative sign, with determinant, and again we interchange to make equal to right hand side. Again we write -1, and -1 multiplied by -1 is equal to +1, and it leads to the right hand side. Now in this question we common 3 from R2. In matrix we common element from the whole matrix, but in determinant we common any number from any row or any column. Here we 3 common from R2, and then we common 3 from column 2, and this is equal to right hand side. In this determinant we can solve it by direct method, but we here use some simple way, shortcut. We add column 2 and column 3 in column 1. It becomes 3a plus l, and then we common 3al plus l from column 1. And it becomes 1 1 1 in column 1, and then we minus R2 minus R1 and R3 minus R1. Rows, when we minus these rows, it becomes like that: 1 0 0 a l 0 a 0 l, and then we expand by column 1. In column 1 there are 3 elements: 1 0 0. Now we expand only with 1. When we cross the first row and first column, there are only 4 values: L0 0L, and we multiply them and get the answer. Here we same process of last question. We add column 2 in column 1. In first column all values are same, we common the values, and then same process, all values are 1, we subtract R2 minus R1, R3 minus R1. Here 1 0 0, and we expand column 1, expand by column 1, it leads to this, and then we cross multiply and get the answer. Second last row equal to the formula, which is equal to the answer. Here we see that 1 1 1 in rows, so we minus column C2 minus C1 and C3 minus C2. Now in row 1 1 0 0, we expand by R1. Here in second row, difference formula we apply to simplify, and then we common B minus A and C minus A, and then we find its determinant, but the order is different from the right hand side. We common minus from first bracket and last bracket, and both minus multiply each other and they become plus, and then the order is equal to the right hand side. Here we add column 2 in column 1 and then common these values. Same way There are difference formula in column 2 and then with common values. This makes this question easy. Here we have determinant A. We find its cofactor. We study about this in the last lecture. A12 equal to -1 raised to power sum of its index. Its index is 1 and 2, 1 plus 2. And when we cross row 1, first index shows row and second index shows column. The remaining values are 0, -2 and 0, 1. Minus raised to power 3, and then we find its determinant is equal to 0. And in A22 -1 raised to power 2 plus 2, and we cross the values second row and second column. And then solve. If the -1 power of -1 is odd number, it becomes minus. If it is even, it becomes plus. And in the same way, A32 -1 raised to power 3 plus 2, and then we write the values third row and second column, and then solve these values. Now find the determinant. We expand it by R1 with 1, 2 and -3, and we know that first number with positive sign, second number with minus sign, and third number with plus sign. And the values in the determinants are except the row and column of the values of 1. If we write 1, then we drop first row and second column. When we write second number, we draw first row and second column. And when we write 3, we draw first row and third column, and then simplify. In this question, we make it equal to 0 without expansion. Here we add column 2 in column 1, and then common A plus B plus C. The first and the second, third column are same, therefore it is equal to 0. In this question, we common 3x from column 3, and it is equal to 0 because column 2, 1 and 3 are equal. In this question, we multiply C3 by ABC, and then these column are equal, therefore it is equal to 0. In this question, we add column 2 and 3 in column 1, and all entries of column 1 are 0. If all entries of any row or any column are equal to 0, it is also equal to 0. Here we multiply R2 by ABC, and two rows are equal, therefore it is equal to 0. In this way, make two determinants are equal. In left hand side, we multiply R1 by L, R2 by M, R3 by N, and same way we divide with the same elements, and then we common LMN from column 1. Now it is equal to right hand side. And in this question, we common 2 from R1, and then we subtract column 2 minus column 1, column 3 minus column 1, and then common b minus a and c minus a from column 2 and column 3, and this determinant is equal to 0. Now here we apply the property of determinant. If two determinants are adding, we add the different values only. If column 3 and column 3 contain different values, we add only these values. Now in this question, very carefully we see that in column 1 we multiply it by c because there is no c, and in column 2 we multiply it by b because there is a and c, and in column 3 there is c and b, we multiply it by a, and we multiply by abc and divide by these values, and then we add column 2 and column 3 in column 1. This leads to the column 1 equal to 0, therefore determinant is equal to 0. Now here we find the value of x. We solve its determinant by expanding by r1 and then simplify. It becomes a quadratic equation. And then we factorize to find the value of x. In same way, we solve its determinant 1, x minus 1 and 3, and then find its determinant. And find the values of x. Now here are 4 cross 4 determinant. If we expand by r1, there are 4 elements. We write 3 and with the sign plus, and we drop first row and first column and the remaining value in the determinant, and next element with minus 4, and we drop first row and second column, and third element is 2 and with plus sign, and fourth element we again write minus sign and drop first row and fourth column, and we name these 4 determinant with a, b and c and d, and individually we solve these determinants and then put these values in this question. Here a determinant, we solve it by the same way by r1, expand by r1, its value becomes minus 43, and then we find determinant of b, c and then d, and we all put all these values in the question 1 and we get the answer. In this way solve it technically, we add c2, c3, c4 in c1. The all values are equal to 3 plus x, and then we common these values, and then in column 1 r values are 1, r2 minus r1, r3 minus r1, r4 minus r1, 1 0 0 0, and we expand it by column 1. When we expand it by column 1, there is only first value is 1 and remaining are 0, and it becomes, when we cross first row and first column, this is a diagonal determinant, and we multiply the values of diagonal. If we have a diagonal determinant, its determinant equal to the product of its diagonal values, like that. Now here we have determinant A matrix, and we find A into A transpose whole determinant. First we find its transpose. We change rows into columns and we multiply these matrices, row 1 by row column 1, row 1 by column 2, and then row 2 by column 1 and row 2 by column 3, and we have this matrix, and then we find its determinant. Now here we have A is a square matrix of order 3. It means it's 3 rows and 3 columns. We multiply it by K, and then we apply determinant sign. Here is a matrix, and now it becomes a determinant. When we multiply a matrix, it multiplies by all values of the matrix. Now it is a determinant. Now we can only common K from each column or each row. Therefore 3K are common, and it is K cube. Now this is the right hand side. Now we find lambda. A and B are singular. A is singular, it means its determinant is equal to 0. We find its determinant and put it equal to 0, and then find the value of lambda. Now we show that it is singular or non-singular. We find its determinant. If it is equal to 0, then it is singular. If not, then it is non-singular. Now here is A. We find A inverse into A is equal to I3. First of all, we find its determinant by expanding by R1. Now adjoint of A is equal to cofactor of all of its element and transpose it. Now we have cofactors A11, A12, A13, A21, 22, 23, A31, 32 and 33. We write A11 by neglecting the row 1 and column 1, and then A12 by drop row 1 and column 2, and then A13 we drop column 1 and column 3, and then we write these values, and then we put their sign. We start from plus, then minus, then plus, then minus, then plus, minus, plus, minus, and plus, and we find all these determinant, and then its transpose, which is equal to adjoint. Now A inverse is equal to adjoint of A over A determinant, and we multiply by it by A, and here we multiply and get the answer is equal to I3. Here we verify A multiplied by B whole inverse is equal to B inverse A inverse. We first multiply AB, and then we find its inverse adjoint of AB over AB determinant. In 2 cross 2 adjoint is very simple. We In principal diagonal, we change their values, replace their values 5 minus 1 by minus 1 and 5, and in the next diagonal we change their signs, and in determinant then we find B inverse, A inverse, and we multiply these values, and this is equal to the right hand side and left hand sides are equal. And in this question we verify AB transpose is equal to B transpose and A transpose. First we multiply these values, then we transpose these values, and next we find B transpose, A transpose, and multiply these values. Now in this question A, we verify A inverse transpose is equal to A transpose inverse. First we find A determinant adjoint of A and then its inverse, and then we find its transpose, and in next side we find A transpose, its determinant adjoint, and both values are same. Here we find A and B are non-singular matrices. Show that A B whole inverse is equal to B inverse. We prove in last question, but here we solve like that. We show that the product of AB and their inverse is equal to I. So left hand side we solve these values AB into B inverse A inverse by applying associative property B into B inverse. We also show this in last question. The product of inverse and its matrix is equal to I, and in last exercise we show that if we multiply any determinant with identity it becomes is equal to I. Same in right hand side, and in this question we show that A inverse whole inverse is equal to A. Inverse of inverse is equal to the same determinant. Okay student, this is exercise 3.3. Now if you have any problem, contact with me. Allah Hafiz. Jazakallah.